Hey class, Mr. Husted here, and today we're talking about Chapter 2, Lesson 6, and we're still in proofs. We're going to talk about proving statements about segments and angles. So we're going to start off with a two-column proof, and this two-column proof is trying to take what is given, measure of angle 1 equals the measure of angle 3, and we're trying to prove that angle EBA is congruent to DBC. Alright, so let's get started. So, anytime you're doing a proof, as we probably know by now, the very first statement should always be the same thing that was up here, which is always our given. They always have to give us some information so that we can move on from that. The next one is stating that angle EBA, so EBA, is equal to the measure of angle 3 plus the measure of angle 2. Now what allows us to know that adding two smaller angles together gives us a larger angle? Hopefully you're able to remember that is known as the angle addition postulate. And what that basically meant was that I can take any two smaller angles and add them together and it will give me the larger angle. So angle addition postulate. Let's see here now. Now what they're saying is that the same thing, measure of EBA is equal to, now it's the measure of angle 1 plus the measure of angle 2. Now what's going to allow us to do that? Well, in our first statement we stated that angle 1 was equal to angle 3. So here we substituted angle 1 in for angle 3. And I emphasize the word substitute because it's known as the substitution property. Now one easier way, I shouldn't say easier way, proofs aren't always easy, but one way of noticing that it's going to be a substitution property is looking to see if pretty much everything is the same except maybe one angle has changed, one segment has changed. A lot of times that will be a substitution. You'll have an equal statement up here above, and then you'll see below where they substitute one in for the other. Okay? So the next we're going to say is that the measure of angle 1 plus the measure of angle 2 equals the measure of angle DBC. So if I'm going to change colors here, so DBC is 1 plus 2. It's the same thing as the other one. It's just the angle addition property. And so now we have to look at the previous three statements in order to get the last one. The last one is now our proof statement, which is at the end. So EBA is equal to the measure of DBC. Now, if I look here, and I see the measure of EBA is equal to the measure of angle 1 plus angle 2, and then here it states the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle DBC. There was a property out there that we talked about it in terms of like friends. If you're friends with one person and that person's friends with someone else, then by this property you would be friends with that other person. So basically we kind of cut out the middleman, and if you remember, that's called the transitive property. So this last one would be the transitive property of equality. It's going to be very important that you are able to locate your notes and maybe make a postulate theorem worksheet of all these different things that we're going over, so that way you have a central location to find everything that you need when doing a proof. Okay? Alright, so a couple more theorems here. So the congruence of segments theorem. Basically it's the same thing as it's the reflexive, symmetric, and transitive. Basically is all the same thing, except now we're dealing with congruence rather than equality. So it's not an equal sign, it's congruence. It means the same thing. Same thing with angles. Okay? Alright, so let's flip on over to the back side. So first thing we're going to do is going to just name the property shown by what we have here. So the very first one, if R is congruent to T and T is congruent to P, then R is congruent to P. Remember, that's that middleman. That's the one we're going to cut out. So when you cut out the middleman, that's known as the transitive property. And that's the transitive property of angle congruence. Now, why is it called angle congruence? Well, it's pretty simple. We are talking about angles in this problem right here, and this is a congruent sign, even though it looks a little blurry. That is a congruent sign, so that's why it's transitive property of angle congruence. Okay, and then property B. If NK is congruent to BD, then BD is congruent to NK. Remember, whenever it just flips the order, so NK was first, now NK is second, that is known as the symmetric, it is known as the symmetric property. So they have symmetry, so it's the symmetric property, and again, we need to be specific about what we're talking about, of segment congruence, because we're talking about line segments, and we're talking about congruent line segments, so it's segment congruence. Okay. All right, so let's talk about the last example here, example number 3, and this is another proof, so bear with us here. All right, so M is the midpoint of AB, so we notice that is also our first statement here, so this is going to be our given. We know that AM is congruent to MB. Now, I would suggest that if you can, mark on here that they are congruent because M is the midpoint. Now, how do we prove that? What allows us to say that those are equal to each other? It's just simply what's known as the definition of midpoint. We know that by defining what a midpoint is, we create two congruent segments. Okay, and then next they're just kind of taking the congruence sign away and talking about the length AM and MB. Again, these are all just kind of definitions. It's a definition of congruent segments. So we know if two segments are congruent, we also know that they are also equal in terms of their length. Okay, on to number 4. AM plus MB equals AB. Again, remember, if we know that two smaller segments add up to a larger segment, we know that that's called the segment addition postulate. Kind of like the angle addition postulate, only we're dealing with segments here. Okay, so now I want you to pay very close attention here. This number 5 looks very similar to number 4. There's only one switch. These have MB has become AM, and that is because up above there we defined that they were equal to each other. So when we do that, we are allowed to substitute into any problem anything that is also equal. So this is the substitution property of equality. So we have two things that we're trying to prove. We're trying to prove that AB is equal to 2 times AM, and that AM is equal to 1/2 times AB. So the first thing we're going to prove is number 6. And basically what we did is we took these and kind of factored them together to get 2AM, which is just a form of the distributive property. It's like the reverse of it. So instead of spreading things out, we are bringing them back together. This is the distributive property of equality. And we'd like to get AM by itself. So there's two things you could have here. Because most of you know that you would divide both sides by 2. We'll call this the division property of equality. But just know that you could also multiply both sides by 1/2 and get the same answer, leaving you with the option to do the multiplication property of equality. So there is, again, some more proofs. Hopefully you kind of understand the progressive thinking that we have to go through in order to make these things work. If you have any questions, bring them with you to class, and we will see you then.